This example is going to walk through the step-by-step process of creating a box using laser cutting. Dimensions of the box will be 120 millimeters along its base and 70 millimeters along its side and top. It's intended to be able to stack the boxes one on top of the other. The corners of the boxes will be rounded and take advantage of the use of kerf patterns. When a base material is cut with a laser, it removes some material. This removed material is referred to as the kerf. Kerf bending takes advantage of these patterns to allow the material to bend, forming a radius. Each pattern has its own aesthetic and bending characteristics, allowing a function and aesthetic to be chosen for the part. Rather than starting from scratch, boxes.py, which is an online box generator, will be used to generate the base pattern, which will then be modified using a vector drawing package. This website has a number of example designs that could be used as the basis for a new design. And in this case, we'll choose the rounded box design and insert the dimensions that are required for our box. In this case, those dimensions are 70 millimeters in the X direction, 120 millimeters in the Y, and finally 70 millimeters in the height. The bend radius for the kerf bend can also be set, and in this case it's set to 20 millimeters, and the type of joint between the sides of the box and the top and bottom will be defined as a finger joint, which will allow us to easily clip the parts together. For geometry like finger joints to work, the software also needs to know the thickness of the material that the box will be laser cut from. The website also allows parameters for the finger joints to be defined to allow a more pleasing fit of the parts together, as well as defining how the kerf bend or kerf cuts are created so that they create the proper geometry as well. And once all the parameters have been put into the website, a vector file can be generated. An example of which can be found through this link if you want to follow along with the next steps. The SVG file or vector file is imported into an open source software called Inkscape. On the screen we can see the page representing the maximum size of material that can be cut on the laser cutter being used for this project, and all the individual elements for the box to be created. In this case, there is only one set of parts, and we require two in order to create a set of stackable boxes. And a logo will be an interesting element to add to the design. Here we can see all the parts being rearranged to make more space for a copy of both the side and the top elements of the box. The components that require multiple copies are copy and pasted like in any other piece of editing software, using Ctrl-C and Ctrl-V. These are then arranged in a way that makes the best use of the material to be laser cut. A vector version of the logo is brought into the software and can be moved to the desired location on the lid of the box. Once complete, the design can be exported to the software that controls the laser, where we can control both the speed and power of the laser in order to get the desired type of cut for the material that we are using. In this design, all of the red lines will be cut all the way through the material using a speed of 25% and power of 90. The green lines will be etched part of the way through the material using a 50% speed and 75% power, and the blue areas will be raster cut, leaving a darkened area representing the outline of the logo, without cutting all the way through the material. Once these settings have been defined, they can be sent to the laser cutter where the parts will be cut out. For this project, the first operation to be carried out will be the raster of the logo. Here we can see the laser passing backwards and forwards, darkening some of the material, and leaving a logo visible. After the raster is finished, an etch is carried out, where the laser traces the edges of the part, not cutting all the way through. Finally, the laser begins to cut all the way through the material. It begins with the internal details like the kerf cut, and then follows up with the external profiles of the parts. While the process might feel slow, it's considerably faster than 3D printing or CNC routing. Once completed, the parts can be easily removed from the board they've been cut from by lifting the material away, or by taking the entire part out of the laser and then popping the parts out of the board. Standard woodworking techniques can be used to glue these MDF parts together. In this case, a small amount of wood glue is being used between flat faces or to support the part at clipped joints or finger joints. We can see, as the top and bottom of the part are placed inside of the kerf bent parts, that the outer part has to be stretched slightly over these internal parts, as the cuts act a little bit like a spring. Once fully assembled, the parts can then be stacked on top of one another, and the part is completed.